been a very income generator for Thailand, also Indonesia, because both countries have a lot of cost. And during the processing, you can see a number of the leftover are generated, consuming around 50 and 60%. But today, I'm going to focus on the skin. Next. And actually, fish skin have been produced as snack, like this one, maybe you're familiar in Singapore, Malaysia is very popular. Certain egg skin is very delicious, but quite expensive, but very delicious meal. Yeah, next. And to increase the value of those skin, so the industry also pay attention on to produce the hydrolyzed collagen and peptide. And what is collagen? Collagen is a protein. Actually, they consist of three triple alpha chain around each other, and each of them have a weight about 1,000 Dalton, totally 300,000. And every third position they can have glycine here, every third position except the 14 resin from N-terminal and 10 resin from C-terminal. And they also contain we call imino, it means like proline and hydroxyproline. And you can see that hydroxyproline is is a unique amino acid in collagen. You cannot find any hydroxyproline anywhere except collagen. Next. And the source of the collagen, we can produce the collagen from skin, from scales, from bone, or even from bladders. Okay, so now I'm going to explain a bit more about how to produce collagen. Even if one want to study on this one, is actually straightforward. So we just start from the raw material, and then we have to remove the non-collagen protein. Basically, they use a collagen solution like sodium hydroxide, and then we have to defat it. You use the skin. That's a very important step because the defatting is related with the quality of the hydrolyte and hydrolyte collagen. And if we start from the skin or scale, we have to do mineralization, and then start extraction using acid. A solution basically uses acetic acid. However, using oil acid, they have like a low yield, so normally they use pepsin here. I'm going to explain later how pepsin can help increase the yield of the collagen. And later we state it using something out principle, and then dialysis and come up with the collagen. All operation going to conduct at 4 degrees Celsius to avoid denaturation. And this is how this is fibers, actually consider turbo collagen and connect together by amorphous region. And what happens is when you add pepsin here, pepsin going to cleave here at the amorphous region and anchor together. And once this part is cleaved, it's kind of easy to reach out by acetic acid. That's why we have a higher yield here. And you can see from here, ASC and PSC for all sample we use either for the marine fish or shark skin or freshwater skin. PSC also always have the higher yield when compared with ASC. And when we take a look from the protein pattern using SS page, we can see from here that this is from sea bass skin and this is sea bass bladders. You can see from under the same condition for reusing or non-reusing. You can see that they consist of the 2 alpha chain and 1 alpha 2 chain. So that can include that it belongs to Taiwan collagen. Not only that, they also contain a dimer we call beta chain and also dimer we call gamma chain. But when compared between the reusing and reusing condition, you can see the same pattern. So this result concludes that those disulfide bonds stabilize the triple helix structure. And this is very important because this got related application. Mostly the native collagen is still stabilized only in the acid condition. You can see the loss in the stability during in the neutron pH. For example, if you want to fortify native collagen in milk, it's impossible because it's going to be precipitated. Next. So this is what we call native collagen because it still have triple helix structure. And in Thailand, they have one product. They claim that they add the native collagen in the drink, and you can observe that the drink they selected pomegranate one because they ask in pH, so that's why they can soluble in the drink. But as mentioned, if you want to add in the fortified or supplement in the milk, impossible because it is protected. Again, since the native collagen is large in molecule, so it's kind of difficult to absorb. Next, so that the people interested in hydrolyzed collagen. And how to produce hydrolyzed collagen actually is quite simple. We have to start from pretreatment similar to how to produce collagen. But one important thing that we have to focus is the fatting process, actually from the skin, because I'm going to talk more on the skin today. That because we have to remove it as much as possible. And then select the hydrolysis process. We select the entire enzyme or condition used, and then end up in hydrolyzed collagen with contained amino acid and peptides. So take a look at cartoon here. So as typical collagens, when we heat it up, in the iteration, those heat gonna have increased energy and break down already bonding here. And you can see this is a more fast one. And in presence of proteases, they're gonna keep peptide one here and come up with a short chain peptide with weight around 0.3 to 8 kilodalton. And this hydrolyzed collagen have a short chain peptide that can easy digestible and easy absorbed into the body. And this is like you see that we start from the seabass skin, and you can use a reactor or use a simple reactor. And this one 100 liters, per reactor, and become a hydrolyzed. Next. And this we focus on calcium sea bass from my study because in our place we have a lot of farm for the calcium sea bass. Next. And factors affecting the bioactivity because actually when we take those hydrolyzed collagen, we also expect some activities. And those activities determined by process used, enzyme used, the enzyme concentration, and of course they determine the peptide and also sequences of amino acid in the peptide, and that affect the bioactivity. Yeah, and this example that effect on enzymatic process on bioactivity of hydrolyzed collagen. Yeah, you can see from here. We use a two enzyme alkylase, this commercial one, and the papain, the commercial one as well. And you can see that we use 0.2 unit per gram, and this is 0.3. But for each of the process, we use 1.5 hours for each process. And this we use two-step process. Start from the papain first, using 0.3 unit per gram for 1.5 hours, followed by alkylase 0.2 unit per gram, and then for another 1.5 hours. And among all 5 samples here, you have acetic acid. You can see the last one, the fifth one, the red level. They always have high activity when tested by different assays. Actually for the anti-acidic assay, we have to use a lot of the assay because each of them they're gonna tell us the different information. For example, the ABTS radical stability activity is indicating the about the hydrophilic structure. And deviant radical stability is suitable for the hydrophobic system, and also FRAP and also metaculating. But among these, you can see this one have the highest deviant radical, and FRAP when compared with other and also ascorbic acid. But metaculating they have slow lower than this one. Yes. And when we use the mass spec, we found that the major peptide found is with 888 and also 1108 Dalton. Next. And when you take a look again, you can see from here the composition of the hydrolyzed collagen. From here, we report residue per 1,000 residue. And you can see here, glycine is 300 something, right? So it means that it considers one third. So it's kind compatible with what I explained within that. Collagen mainly have the glycine with third position. So this one confirms that our results is right. And also they also contain the proline and proline called amino acid. And from this one, the red label indicate the hydrophobic amino acid. So since they have a lot of hydrophobic, those can play a major role in the high activity and acidic activity of the hydrolyzed collagen. And apart from that, we also study on the sequence of amino acid or peptide. We synthesize the peptide, and you can see again, they have glycine with no position. However, the sequence is different. The first one, you can see glycine, phenol, glycine, proline activity. We're going to have the highest radical stability activities. But for the last one, vitamin, leucine, glycine, proline 1, they have the lowest activities. Yeah, and what we have to consider when this is used as raw material for operation of hydrolyzed collagen, the first thing you have to consider is they have a disorder in the resulting hydrolyzed one. This is not desirable. Next. So why is it happening like that? Because when we extract the oil fat from the seabass skin, you can see that they're rich in polyunsaturated fatty acid here. They consider around 41%. Also have monounsaturated fatty acid around 22%. And then it's kind of protein. The oxidation, as you may know that oxidation takes place like an initiation, propagation, and what happens is, lastly, those kind of primary oxidation product like hydroxide is composed to oxidation product like aldehyde, ketone, acid. Those compounds that contribute to disorder. And now this is example that we developed in the lab. We also start by using the combination technique, start by treatment of the fish skin using polyliquid film based on the electroporation to make the little pore in the skin. And also we use lipase solution in impression become impregnation techniques. And this is a vessel that we develop. Actually, basically, we start from the skin and it's subject to PM. And you can see the pore here, and we put the lipase solution and then vacuum first. But during vacuum, those gases in the hole is sucked out. And when we release the vacuum, those lipase solution can get into the pore and hydrolyze the lipid effectively. And you can see from here, we stain the lipid using non-UA, and this is a control one behind the treatment. And this was the best one when we did, and you can see that just only like a small part, fat retained in the sample. And also we also study on some volatile compound in the hydrolyzed collagen we produce from our sample. The best one that we select, we use the combination together with lipase. And this another control one we use isomer isopropanol instead of lipase. And this one control without any treatment, except using PF and combination. You can see from the label here, you can see the less abundance of the aldehyde, ketone, alcohol, and also furan found in our sample. So it's indicating somehow that they have the lower fish odor. Next. And when we do sensory test, we found that the red bar is the hydrolyzate produced from the skin with the treatment with lipase using vacuum impregnation. You can see either for fishy odor and also fishy flavor is the difference. You know that odor is just made by flavor, you have to perceive in cavity. And you can see from here, this result confirmed that our treatment of skin is suitable to produce a hydrolyzed collagen without the fishy odor. Next. And now, because a lot of people interested in skin nourishment, because once they take hydrolyzed collagen, they expect to have the very nice skin younger. Yeah, take a look. Yeah. This one is very important because aging, when we get older, they have aging or wrinkle happening here. So can hydrolyzed collagen be of help? That's a question. Next. So actually the hydrolyzed collagen can, they have function, they are free amino acid, they kind of serve as building block for formation of collagen and elastin fibers. And also collagen oligopeptide as ligand, binding to the receptor on the fibroblast membrane and simulate the production of new collagen of elastin. I can show you later about this. Yeah, next. This is the experiment, but not all belong to a group, but they use animal trial, they use rat, and they fed with the 12% hydrolyzed collagen compared with the control one using 12% sodium glycinate. These are the placebo. And after 4 weeks, they sacrifice the rat and take the skin and do Western blot against the type 1 collagen and type 4 collagen. You can see from the one that treated with fed with the hydrolyzed collagen, the larger band of the type 1 collagen, also larger band for type 4 collagen. And the question is why type 4 collagen? Because type 4 is located in the basement of the skin. So once the basement is weak, so you can get the wrinkle easily. And also, this study they indicate somehow that hydrolyzed collagen they can inhibit the metalloproteases. Again, once the collagen is break down or hydrolyzed by proteases, it's kind of weak metric, and then you can get the wrinkle easily. Next. And this our study, we use fibroblast cell, and we mix together between fibroblast cell and the ascorbic acid due to different ratio. And we found that when we use hydrolyzed collagen with the ascorbic vitamin C at 2:1 ratio, you can see that the cell proliferation is highest one, the black bar here, and it's kind of dose-dependent manner. And also we monitor the collagen production. Again, we found that this sample have the highest produce of collagen from the fibroblast cell. And that's why in the market, always you can see hydrolyzed collagen plus vitamin C. That's because it's has synergistic effect. Also, when healing, there's one study where we have done overlap. We start from the seeding the fibroblast cell, and we use the sterile scratch assay. Here you can see we use the sterile tip, make a scratch here, like mimic the wound. And then later we incubate with the hydrolyzed collagen at different levels. And you can see from here with the higher level of the hydrolyzed collagen, the gap is kind of like less, become less, and you can see from here. This is like a qualitative data. And this is indicating that they can use it for healing. Next. Apart from that, it has been known that if you take hydrolyzed collagen often, it's good for bone and joint because osteogenesis is one. Okay. And before that, actually we use a pro-osteoblast cell and test for the toxicity because when we use the cell line, we have to test it concentration effect or cause toxicity or not. So in this range, 50 to 800 is okay. They don't have toxicity on the cell. Next. And this one is kind of interesting because actually we seeded the osteoblast cell as well. And we see that in people 21st day, and we stain using glycerin red S, and the dark one, that is calcium nodules. And that one you can see the 100 and 200, they have a lot of nodule, calcium nodule. It means that they can produce a lot of calcium. And to confirm that, we just drain out all solution and then dissolve this kind of the nodule by using 10% acetyl iridium chloride for 10 hours, and then measure those kind of solution, the absorbent 405. And you can see a lot of the absorbent C, so it confirms the cancer formation. And in fact, actually, what we have done for hydrogen in Thailand, I don't know here. So they use the for, you see, beauty drink. It means that once you drink a lot, so you can have the like a younger and also the nicer skin, like this. Yes. And this are experiment we prepare the chrysanthemum tea and that with hydrolyzed collagen or hydrogen and from 0 to 500. But we still write, but I have the 100 to 121 degrees Celsius for 7 minutes to still like that. And you can see from here, when we add more, we have the like a darker color. I mean, the darker, that is because of Maillard reaction. I'm sure that you know Maillard reaction is not necessarily Browning reaction. So in that one, because of sucrose, actually we don't put the glucose, but sucrose under the high temperature, high pressure, they can break down to glucose and fructose. And those sugar is really sugar and undergo like a glycation, and it can form the Maillard reaction. And also a function of steroid time up to 6 months. Also they have the slightly higher Browning intensity. That becomes Maillard reaction as well. Yes. And actually, the last slide, actually, if you want to have like nice skin and also like a strong bone and good joint, you can maybe like put in the drink coffee or the drink for maybe a couple spoons of hydrolyzed. Yes. Yeah, and I'm gonna come up summary the fish skin cancer as potential source of the collagen to increase the revenue for the processor. Hydrolyzed collagen containing peptide from fish skin has been have a high market value and show the nutraceutical property like soft skin nourishment or bone strengthening. But however, effective process and logic technology must be developed to tackle the problem as with the fish order. And the fishery resources can be sustainable and maximally exploited. Thank you so much.
Thank you very much for fascinating presentation, Professor. Okay, let me summarize on one point from your presentation. We can convert the parts of marine resources that usually labeled as waste product can be converted to high value added products. Okay, now we move to the discussion part. So if any of the audience want to question, please. Okay, 1, 2, okay. We have limited time, so I'm really sorry. We only have 2 questions for answer. Okay, the first, please, Prof. Ineke.
Thank you very much for the chair. Very nice presentation actually. It is very inspiring for us because we also do the similar study, but we use to extract the collagen from fish scale. Have you ever tried?
Yeah, we tried, but the problem is yield is quite low. Yeah.
Oh,
so actually, I tell you that mostly the industry they import oocyte because oocyte is being derivative scale from abroad and it's bulky. And when they do hydrolyze it like this, of course they don't have problem with fishing order that we face, but the yield is low. And you maybe you can have a problem.
So you have compared the two.
No, we don't
sources
because we also publish was already for that one, but yield is quite low, so that's why it's not like attractive for the industry.
Yes.
Yeah.
The quality is not
like
the one from fish skin. But we have tried to use it to use a Vistar mouse to try to explore the anti-diabetic. Yes, and it works. Okay. The second question: what acid you use to extract the collagen?
Normally, the commonly is acetic acid.
Acetic acid.
Yeah, it's a commonly, but you can use citric acid as well. But the common one is acetic acid, but it's got the cheap price as well. Yeah.
How about the other, for example, organic acid? Have you ever tried?
Which one? Organic acid?
Yes.
You can use it like acetic acid or organic acid. Citric acid also that one. But phosphoric acid somebody used, but the among all they found that acetic acid is the best one, and also the reasonable price. That's why the acetic acid, you can see a lot of paper they use acetic acid.
Thank you. And the last question: How is the price of your
The price?
very valuable collagen?
Oh, actually, we have to consider. Actually, we license one this time that we do patent, and we have like a transfer technology to the company. And but actually they have several factors determine the price of the finished product. I can't remember, sorry, but affordable I think, because if we use a larger scale and we have our own raw material, I think it should be fine. Yeah.
Probably you have also tried to make it nano collagen.
Nano one. Now we have one project about tripeptide and dipeptide, because this one is very important because of the competition in the world market. We import tripeptide, dipeptide from other country, but so that one we have to enough with our own technology. So we also get grant from we call PMUC, from Thai government. Yeah.
I see. Thank you very much.
Thank you, Ajahn, for the answer to Ingat. Okay, the last question. Okay, please.
Okay.
Please introduce yourself. Okay.
Okay, thank you for the opportunity. Now I want to let me introduce myself. And I am the politics tutor from the chemistry study program 2020. I want to asking about what is the most compound that responsible for the characteristic of hydrocollagen. Thank you.
That's a good question, because if you use those kind of skin as raw material, that you're gonna face the fishy odor all the time, and that's why we proved by extraction the fat, and we found that they have a rich PUFA, and PUFA is prone to oxidation. All right. So the most important thing that we have reported like aldehyde, like heptanol, hexanol, that contribute associated with the fishy odor. Yeah. Is it? I answer your question? Yeah. It's a volatile compound, and then why you can sniff easily, even odor or flavor. That's why with odor you can smell like fishy. But flavor is kind of more intense when you take it in your mouth. You can perceive healthy as well. So we call flavor. So there are different meaning between odor and flavor.
Okay, thank you very much, Professor, for your time with all of us today.
Hopefully it's going to be useful for you, not waste your time. Yeah.
Okay, that's all.